Okay, recording has started now, guys. Okay, so it's better for me to record Zaid, okay, not you, so that I can upload to YouTube and share the link later to everyone.
I know, I
Uh,
just made the request.
yeah, don't ask me to record. I can do it myself here. It's better for me if I record. Okay, now let's start. Well, I would like to take you first in a tour, like about F3 robot, how the real one. I'm talking about the real one, so that you will know how to program the virtual one. So I guess some of you have a good idea about EV3 before, and maybe some other students are not. So I'll try just to take you on a tour, and it will be really fast. Okay. Because I don't want to waste much time doing this. It's just an introduction. I would like to take you to the real virtual robot so that we will do the programming together and try some codes. Okay.
Okay.
So now I'll be talking. In case you have any question, you can use your hand. Okay. Raise your hand if you want to ask. Stop me, ask about anything that is not clear because I'll be talking fast. Okay.
Okay.
Okay, first of all, okay, I would go to the different designs of different robots, but this is this elephant is the one that you can see or you can build using an EV3 kit. Okay, so forget about the goals or objectives behind teaching robots in education, so we can read them later. That's how the EV3 kit looks like. That's the main kit. And there's also another one, it's called the expansion kit. The expansion kit will contain extra pieces that you can use to build your robots. But this is what you get in your main kit or the basic kit. That's the EV3 robot. You have the brick and two large motors, one medium motor, and ultrasonic sensor that measures the distances using sound waves, one color sensor that measures the colors using reflected light intensity. And I'm gonna explain these things if they are not clear. Two touch sensors and one gyro sensor. The gyro sensor is like the compass that lets the robot know which direction it is moving to. Okay. And the expansion kit, you will not receive any of these parts. You will receive these parts, a large number of these pieces back again, but not these electronic parts. So the expansion kit, you will receive no one of these hardware devices here. They only come in the basic kit. Okay. So what is an EV3? It is the latest educational robot that can be reconfigured and programmed according to different tasks to achieve educational goals. And now the latest educational robot, this sentence is not correct anymore because now the Spike is the latest one. Okay. This is how you're gonna connect the motors to the brick. So the ports here, they are numbered A, B, C, D. This is where you will connect your motors, and these ports here, which are numbered 1, 2, 3, 4, they are used to connect your sensors. Okay, and of course it depends on your design. You should not connect all of these things at the same time. It depends on your design. Sometimes I'm using two color sensors and no touch button or touch sensor, so it's okay. Sometimes my robot doesn't need to measure the distance, so I will not use this ultrasonic sensor. The EV3 brick unit is, it can connect up to 4 motors and 4 ports for sensors, illuminated control buttons. There is light here, and there is a USB port and external memory card slot. It has also Bluetooth and Wi-Fi connection capabilities. Yes, Zaid?
Yes, teacher. I wanted to ask you that, for example, the motor sensors What type of the sensors? They must be like placed in the brick in a specific pattern.
Yes, I said you cannot.
Like this.
Yes, you can connect the motors into A, B, C, D. Only these ports. The 1, 2, 3, 4 ports are only for sensors. So you are not free to connect the
Ah,
motor to 1, 2, 3, 4. No, this doesn't work. Okay. So sensors have ports and motors have different ports. But it's okay to connect your motors anywhere in A or B or C or D, whatever. No problem.
okay.
So this is how the brick, the EV3 brick looks like. That's the motor output ports, and this is where you find the USB port for connection to computer, and USB port for Wi-Fi. Actually, you don't need this. Wi-Fi works immediately without anything. The memory expansion card, SD card, you can insert an SD card here with some programs or codes that you made, but it's okay to put them on board the EV3. The EV3 has memory that will be enough for like 15 projects or something. So it's fine. Rarely you can use this memory card expansion. And the 1, 2, 3, 4 ports are the sensors input ports, and these are the navigation buttons, and that's an LCD display screen. What I like most about the EV3 and I don't like anymore about the spike is that there is no screen on the spike and there are no buttons. So actually you could do lots of things on this brick itself without the need for a computer. But the spike one, you have to use a computer because there is no screen and no buttons there. Okay, that's the large motor, and it's a strong motor and accurate motor. There is a sensor in this motor that knows exactly the location of the motor itself. So when you start your robot, the motor will be counting from 0, and then, for example, I asked the motor to turn like 100 degrees. So the motor has a sensor inside it that knows exactly when it reaches to the 9 degrees or 180 degrees. Okay. The medium motor also is the same. It's a small one in size, but we often call it a medium motor. But there is no small motor actually in EV3. So you have large and medium only. It's really accurate and it has quick response and easy to attach, of course. The gyro can measure orientation, balance, and direction of the robot. It's similar to the sensor in your phone that knows the orientation of your phone. When you make your phone, horizontally, or you flip your phone horizontally, it will change the image of a video, for example. And instead of showing the video vertically, it's gonna flip to horizontal view by itself automatically. Okay.
Okay.
The ultrasonic sensor is a sensor that uses sound waves, ultrasonic sound waves, to measure the distance, like bats. Actually, the scientists who designed this sensor, they learned this thing from bats. You know, how do bats fly in dark caves at night? They use sound waves. They, transmit sound waves like screams. And when the screams are reflected back, they can measure the distance or in case there is a wall or there is no wall in front of them, depending on the time that takes the sound to go forward and reflect back and come back. So actually, this sensor works like a microphone and a speaker. The speaker will transmit sound waves, and the microphone will receive these sound waves back. So it's like throwing a ping pong ball on a like a wall or something. So if you are far away from the wall, the ball will take time to travel towards the wall and takes time to come back towards you, right? So if you are near to the wall, this time will be shorter. So the ball will travel faster and will bounce and come back to you faster. So this is how you know whether you are near to the wall or far from the wall, measuring the difference in time that the sound waves take until they are reflected or bounce and come to you back. This is how these sensors work, and they use this value of sound waves speed, the speed of sound. There is a specific value for the sound speed, or the speed of sound. This value is taken in calculating the speed with which the sound took time to reflect or bounce from the wall back to the sensor. So it uses this value of sound speed to measure the distance. Okay, guys? Okay, the color sensor can detect 7 different spectrums of colors, okay, and can differentiate between white and black backgrounds for sure, can measure intensity of reflected light, can measure intensity of ambient light. What does all this mean? First of all, what is this sensor about? Is it a camera? Because it looks like a camera that can know the colors. Actually, it's not a camera. It's just what we call photosensitive sensor and light transmitting LED. So this LED will transmit light, and light will be reflected back on this sensor that will measure how much reflection takes place. So for example, I'm giving 100% of light here. How much percent came back to the sensor? If like 90 degrees, 90% of the light was reflected back, this means that the robot might be standing on white background, right? Because
Yes.
white reflects
the
more
most.
light. Yes. What is the thing that reflects 100% of the light?
Sorry?
What is the thing that can reflect 100% of the light backward?
A glass or a mirror?
A mirror, yeah, that's exactly the correct answer. So the mirror has the ability to reflect back like 100% of the light that falls on, okay? But in case you have a white color, you don't expect you to receive back 100% of the light, but something more than 90, right? So starting from 90 and above, that means a white color. So how about like 5% or 10% of the light was reflected? That means black. Yeah.
Black.
Actually, this is how this sensor measures the colors, because each color will reflect a specific value of light backward. Okay. So this is how it is able to differentiate different colors depending on how much light was reflected back. And this sensor will output this LED will output not white light, but this one. It depends on how you're gonna use it. It sometimes transmits RGB, or red, green, blue colors, and it will measure how much red came back, how much green came back, how much blue came back, and this is how it knows the different colors. Easy now?
Yes.
So
Yes,
this is
mister,
what we
yes.
call intensity of reflected light. This is where we use this this sensor to use the measurement of intensity of reflected light to measure black and white, differentiate black and white, for example. Intensity of ambient light. This means like I want to know how much light is in this room or in my classroom. So you can use this thing to measure how much light is in your room. If you are opening the curtains, for example, with the artificial light or the electricity, so this will give a specific number. If you are using only the sunlight, this will give you another number. If you are using the torch of your phone, it will tell you exactly how strong the light is. So that's called the ambient light, okay? A touch sensor is just like a press button. So this button, this red part will go inside if this sensor touches something, like a wall. If this sensor touches a wall, the red part will go inside. So it's like a switch. And the robot will know if there is something that has been touched or not. And there are three states for this sensor. They are pressed. Is it pressed or not? Is it released or not? Is it bumped? Bumped means like you touch it quickly and release your hand. You know, press it fast and release your hand. So you can measure these three states. Okay, the building parts look like these in the tray. Once you take them out of their bags and put them in a tray, they should be sorted like this. And the beams, this is what we call the beams. So this one is 5 holes beam, that's 7 holes beam, 9 holes beam, 11 holes beam, 13 holes beam, and 15 holes beam. The arms, that's the small L shape. Actually, we refer to it like this: small L shape and the large L shape, and that's the T shape, and that's like 45 degrees, 45 degrees small, 45 degrees black. They are the same, but again, the number of holes here are different. Okay, and that's a J shape. That looks like a J letter when you hold it. So you use these things to build your robot, and these are called axles. Okay, so that's like 3 holes axle. If you measure this,
What do
it
they
will take.
do?
They look like the axes for the wheels, for example. If you are going to attach the wheels to the robot, you use the axles. They will connect the wheel to the motor.
Or Mr. We use them to connect the medium motor to the wheels.
Yes, yes. They look like a plus sign. If you look from the side, this will look like a plus sign. Okay? They are not clear here in the images, but they look like a plus sign from the beginning, the side. If we go back to the motor, okay, you see how the motor connects here needs something that looks like a plus. And here also, that large motor, also there is a plus. So you insert the beam here and connect to the wheel, okay?
Okay.
Also this touch sensor, maybe your touch sensor is back in your robot, so you can add a beam so that it will touch the wall from 10 centimeters, 15 centimeters. So I might put a beam here so that the beam will touch the wall on a distance. Okay, so actually this is how you're gonna measure the beams. So, or sorry, the axles. You put the axle beside the beam, and here you can measure the axle. That's a 12 holes beam. Sorry, 12 holes axle. This one is 10 holes axle, 9 holes axle, 8 holes axle, and so on. Okay. That's the beam connecting or connectors. This is how they look like. Actually, we refer to this one, we call it H connector. That one is called llama. Okay, because it looks like the llama animal, if you know about
The llama.
Yeah, that looks like the short camel. So it looks somehow like a llama. So we give these things names, but again, it depends on every person. Some other persons give other names. So these are the nails, okay? So in Arabic, so some Saudi students say musmar, okay? Because this one is the connector that you use to connect like 2 beams together, like a beam with another piece together. They often give me a musmar, okay? So actually, even in English, they are called nails. They are used to fix things. This one connects 1 hole to another 1 hole, like 2 beams together. But this one can do extra, like the blue one, for example. It can connect 1 beam here and 2 beams to the other side. So this piece can connect 3 beams together or 3 parts together. Okay, what is the difference between the black and gray one? The black is harsh and the gray one is smooth. So if I connect 2 beams with a black connector, a black nail, they cannot move freely. There will be friction. But if you connect them with a gray one, they can freely move if you move them by hand, they will move freely. I can use this one also to connect small wheels to the body of the robot, because anything you connect to this one can move freely. That's called, like a washer. A washer in Arabic is like samula. So, or a spacer. Actually, that's one
Samoa.
spacer, that's a double spacer. Yeah, the double spacer is the same size as a beam. So this width is the same width as the beam. So maybe I'm connecting a wheel that needs to be far away from the body of the robot, or there will be friction. So I will use a spacer like this one. So imagine that I have the motor here, large motor, and the wheel. But if I connect the wheel immediately to the motor, there will be friction between the body of the motor or the body of the robot and the wheel. So this is where I use a spacer like this one to give space between the motor and the wheel. Okay. So this connector looks like a connector or a nail from one of the sides and an axle from the other side. So it's also sometimes needed during the construction. These are the bridges. That's what we call O-frame, because it looks like an O letter or O shape. That one is called a ladder or an H shape, H connector. Okay. These are gears, and gears are responsible for transmitting the movement from one part to another. Like I connect one gear to the motor and other two gears beside it. So the movement will be transferred from the first gear to the second gear and to the third gear. Easy? I don't want to go that much
Yes,
into
it's
these
easy.
things because actually I prefer to teach these things practically. These are the cables that will be used to connect the motors and the sensors to the brake. Okay? And that's how it works. That's the program of EV3. That's the programming software on my computer. I can show it to you now. And actually, this is how you're gonna program everything. This explains everything about the brick screen, the different controls, and that's the programming software on the PC. And it uses blocks like these ones to control the movement of robots or the motors. Sensors also have blocks and so, but we need this not anymore, okay? Actually, that's the old EV3 program. You can still use it to program EV3 robots, but now you have the EV3 classroom software, which is better. And the Spike one, which is the new one, and also works better than this one. So I don't want to go too much into this, but this is how the code looks like. For example, this one is a loop. Yes.
The program, so we can program the robot, the everything. Is it like blocks or writing like Python or JavaScript?
You have two ways. This one is the blocks. The other one is to use Python also. Yeah, you have the option to use Python to program the EV3 brick. Okay, but not all the competitions will allow you to do this. So the WRO competition asks you to use whatever programming language you want. But the first Lego League, for example, they ask you to use the EV3 style. Okay, and actually I can give you a a look at the program of a competition. How does it look like? And it grows really, really complicated and really large. Okay. So that's a simple code, like the yellow one, the long one, or the big one is called a loop. So whatever inside this block will be repeated once it's finished. So like, for example, this block moves the two large motors, which are B and C, controlling the movement of the robot. So like on power 50 for one rotation. And after that, the motor will go, or the robot will go to the right side at power 50 for one rotation. So the more I can read the code like move forward for one rotation, turn right for one rotation, wait 1 second, and repeat these things back again for 4 times. That's how you can read this code. Okay. I should know now, if I read this code, I should know how will the robot move. So I said the robot will go forward for 1 rotation, turn right for 1 rotation, and wait for 1 second, and go back, forward, right, forward, wait 1 second, forward, right. Okay, this will do what at the end? This will draw a square. So you make this code when you want your robot to draw a square. Forward, 1 rotation, right, 1 rotation, forward 1 rotation, right 1 rotation, forward 1 rotation, right 1 rotation, forward 1 rotation, right 1 rotation. This will draw a square and then stop. Okay. Using the color sensor again, like this one, for example, the robot will move forward at power 50 until it sees black color. This is what these blocks tell you. I should put motor stop here. So after it sees black color, it will stop at the black line. And this motor will keep moving until it sees black color. If it doesn't see black, it will keep moving, okay? Because I didn't tell the robot to do anything else. Keep moving until you see black. But what happens if it doesn't see black? It will never stop. It will keep moving, okay? So this code, for example, here tells the robot to move forward at power 50, and when it sees black, okay, it should go back and sorry, it should continue moving forward. So I see first the black line, and it's okay. I keep moving, and then I wait until I see white, and then I keep moving, and I see the second black color. I will stop. So I want the robot to move to stop at the second black line, not the first black line. This is how you're gonna make it. Okay, let's see what does this code teach or tell the robot to do. So this is a loop. Okay, so move forward or keep moving forward until you see black color. And then if you see the black color, exit this loop and stop. So what does it? What happens if the robot doesn't see black line? It will keep doing this, moving forward. Yes. So let's build a line follower robot. I want the robot to follow this black line. So I should tell the robot that if you see black, you go straight. If you see white, you go backward to the side that you that has been deviated from. So if it goes right and so white, it should go left to see the black again. And if it goes too much to the left and sees white, it should go right to see black again. So if you make this code, for example, the robot will move into zigzagging, okay, zigzag-like movement, so that it will keep itself on the black line. Easy? So I'll move right, turn right for 10 degrees until I see white. Then if I see white, I go backward to the left side until I see black, and I keep doing this trick, okay? So that the robot will keep moving on the black line. We can go to the switch block. Switch is like if statement. If you see this, do that. If you see something else, do this. Like I tell you, Zaid, go to the Tamunat and buy Mara'i yogurt, okay? If you find the Mara'i, buy Mara'i. If you don't find the Mara'i, buy Nadik, okay? That's how it works. That's the if, okay? And you can have more than one condition. So there are 2 conditions here, but you can add more. So now, yes, you can see here the switch block. So I can give the condition here, like if the touch switch equals to 1, means it is the touch button is pressed. What should I do if this is true? And if it is not pressed, what should I do? Okay. Now we will use this switch block to tell the robot what to do. So here, I ask the color sensor. If you see color number 3, which is like white. So if you can see white, turn 50, like minus 15 degrees to see black again. And if you see if you see already black, keep moving to the right and repeat this back again, so that the robot will keep doing this trick, and it's gonna move forward again in zigzagging like movement using the ultrasonic sensor. Okay, that's how you can use this ultrasonic sensor. Like I ask the robot to move forward until the distance is less than 15 centimeters. So if the distance went less than 15 centimeters, it means that there is something in front of the robot, right? So what should the robot do at this case? So if I see the wall, should I stop, or maybe I turn right or turn left and see somewhere else to move? So this block tells the robot, keep moving forward until the distance is less than 15 centimeters. And when the distance is less than 15 centimeters, turn right at 50 degrees, okay, for one rotation, and then repeat back again. So turn right and keep moving forward until the distance is less than 15 centimeters. And if the distance come, like if you see the wall, okay, turn right and move forward again. So what should the robot do in this case? It will keep moving until it sees something, turn right and forward again until it sees something, and will take turn right and keep forward again. Okay. That's like programming the robot to solve a small maze without hitting the walls. So if your robot is here, so you will ask the robot to keep moving forward until it sees like 10 centimeters. And if you see 10 centimeters, you should turn right and move forward. Okay, so it will move forward until it sees 10 centimeters here. So it will stop and turn right. See, turn right and move forward until it sees 10 centimeters, and it will turn right like this. Okay, that's how you can program your robot to solve the maze. This is how it looks like. So attaching an ultrasonic sensor to the robot will make the robot like as if it has two eyes. Okay, it can see something in front of it. Yes, Zaid, ask again.
Yes, teacher. The programming, يعني the competition, when we want to program the robot, the virtual one, it will be like this one, or it will be...
No, this is why I told you that I'll go through this very fast, because this is somehow different from what you're gonna use on the competition. The competition uses blocks like Scratch, exactly like Scratch. It's not the AV3 blocks.
It's not complicated.
Yeah, it's not complicated at all. So if you are used to use Scratch already, it will be really simple for you. I'll show you, but in the second part of this session. This session will end at 40 minutes. That's after 4 minutes from now. And by the end of this session, I'll create a new link to the next session. It will also be 40 minutes to show you on the website how you can program your robot, and maybe we can perform some missions also. Okay?
Is that 40 minutes?
Yeah, we have 4 minutes for this meeting to end, and I'll start another meeting, okay? Someone is writing on the chat box, but I didn't see this. Okay, I saw the chat box, but there is nothing important there. So move obstacles out of field. So if I want to program my robot, for example, to find these cubes and push them away, it looks like the sumo robot competition somehow. So first of all, you would start with this exercise that you program your robot to go on this ring and try to find the obstacles and push them outside of the ring, okay? So this is how the code looks like. Okay, so again, there's a loop. The loop will repeat all the process back again when it is done. So I tell the robot, for example, to if you see this color, which is black, The black color means that the robot is now on the ring, right? So if you move this robot up, it will stop moving because it cannot see black anymore. And at the same time, when it sees this white, it should not go forward anymore. It should go backward to stay on the black float. So I tell the robot, if you see black, what should you do if this is correct? Okay, if you see black, so you should go forward. And again, go forward and wait until the distance is less than 50 centimeters. If the distance is less than 50 centimeters, okay, I should push forward, push the cube forward at power 100 because it might be heavy. So what if I didn't see this distance, or the distance is not less than 50? So I keep turning to search for the obstacles or something on the floor. طيب, what if I cannot see black, but now I see white? White means this white border, and I want my robot, I don't want my robot to fall down out of the ring. So the robot should back up, right? Should go backward for one rotation. And now after moving backward, it will be able to see black and repeat this part. Can you understand the code now, guys?
Yes.
I guess it's simple, right?
Yeah.
Yeah, somehow.
You can.
Yeah. Now, challenge is a sumo robot competition. So instead of having an obstacle on the mat or on the ring, now I'm gonna replace this with another robot, and the other robot will have the same code. So you will be searching for the enemy, and he is also searching for you. Whenever you find the enemy, you have to push it outside the ring, and you should not pass this white border. That's simply the sumo robot competition. Okay, that's how it's gonna work. Again, the same code, and that's it. Okay, so this was the sumo robot